Hello students, welcome to chemistry class with Mr. Odesola Adiola. This video is brought to you by Igota Virtual Learning. And this class today, we are going to continue from the previous class we had on stoichiometry and mole ratio. In the previous class, we have looked at stoichiometry, how we can balance equation, what a mole ratio is, stoichiometric conversions from mole to mole, mole to mass, and mass to mass. In today's class, we are going to be looking at limiting reactant and percentage yield, and how we can solve for stoichiometric questions that involve mass, volume, and volume. A chemical reaction will proceed until all of one reactant is used up. The reactant that is used up is known as the limiting reactant. The leftover reactants are called excess reactants. Take for instance, we have A plus B producing C plus D. During the reaction, B is used up such that its concentration is reduced to 0. That B is our limiting reactant, and A is our excess reactant. Now, how do we identify limiting reactant? We can determine the limiting reactant in a reaction when we are given the mass of the reactants. Let's take for example, when you have 40 grams of sodium hydroxide reacting with 60 grams of sulfuric acid. If you have to write the balance equation for that reaction, you have NaOH plus H2SO4 giving Na2SO4 plus H2O. When you balance the reaction, and to calculate for that, we can convert the mass of the reactant into actual mole of reactants available. That means we want to convert both 40 grams and 60 grams to mole. Remember, we know that mole is equal to mass over molar mass. That's so the mole of sodium hydroxide is 40 over 40, and that one will give us 1 mole. And then the mole of H2SO4 will be 60 over 98. That's 0.612 mole. Okay. The step 3 to do is we want to relate the mole now. We want to compare it. The actual mole of sodium hydroxide is 1. That of H2SO4 is 0.612. Stoichiometric mole, or the mole from the equation, is sodium hydroxide is 2 and H2SO4 is 1. Therefore, if you divide by 2, you are going to have 1 mole and 0.5 mole respectively. If you divide by 2, therefore all of the 1 mole of NaOH is used up. All of the 1 mole of NaOH is used up, and there is excess left of 0.112 for H2SO4. So NaOH is our limiting reagent, while H2SO4 is our excess reagent. Again, if you want to compare, observe that you have actual mole, stoichiometric mole, and divide by mole ratio. So if you have if you divide both sides by 2, you have 1 and 0.5. So 1 minus 1, that's actual mole by, and the one you get, that's 0. Then 0.612 minus 0.5, you are left with 0.112. So your excess reactant is H2SO4, and your limiting reactant is NaOH. Now, when you calculate the mass of product when given the mass of reactant, for instance, maybe you are given the mass of reactant and want to calculate the mass of product, for instance. How do we do that? You have 1 mole of NaOH produces 1 mole of if you go back to that equation, 2 moles of NaOH produces 1 mole of Na2SO4. But to solve that very well, don't forget that we had to the formula we started using, the mole of NaOH, and of course the over the mole ratio, and so we have 1 mole of NaOH, that's the number of moles of NaOH times mole ratio of the product over the reactant, like we have been doing, multiplied by mass of the multiplied by the molar mass of the reactant. It will give us 71.0 gram of Na2SO4. Okay, so how do we calculate the percentage yield? To calculate the percentage yield of that of the reactant, we first balance the equation, do a mass to mass conversion between the known and the unknown. You use the given actual yield to set up the ratio. So actual yield is usually the amount of product that was actually produced, that is found out in that one is usually found out in an experiment. You have the theoretical yield, which is the maximum amount of a reactant produced. I usually find it out from your stoichiometry calculation, and then your percentage yield is the actual yield over theoretical yield multiplied by 100. So let's look at a typical example of how to calculate a percentage yield or percent yield. Aspirin can be made from salicylic acid and acetic anhydride. What is the percent yield of aspirin when you mix 13.2 gram of salicylic acid with an excess acetic acid and obtain 5.9 gram of aspirin and some water? So the actual yield during that experiment of aspirin is 5.9 gram from that equation, from that question. So don't forget 5.9 gram. So the 13.2 gram of salicylic acid, we are going to work it out in such a way that we are going to now use it to get the theoretical yield of aspirin. The value of salicylic acid that we got, we are going to use it like stoichiometry, like we are going to use it to get that of aspirin, so that we can now conclude the calculation. So let's look at the balance equation. This is the balance equation for the reaction. So we want to calculate the theoretical yield of that of aspirin. Our limiting reactant is salicylic acid. Is the one that is used up. So we know that 13.2 gram of salicylic acid will be equivalent to 0.0956 mole of the salicylic acid. How do we do that? You divide by the molar mass. You want to convert the mass to molar mass. So that's what we did here. So we got 0.09656 mole of salicylic acid. Now we now want to relate them stoichiometrically. Don't forget 2 mole of salicylic acid is equivalent to 2 mole of aspirin. Therefore 0.0965 mole of salicylic acid would now be equal to 0.0965 of aspirin. That's stoichiometry. We have related them to them. Then that means we have gotten the mole of aspirin. We now multiply it by the molar mass. So we get 17.2 gram of aspirin. This is the theoretical yield of aspirin, and then we have been given the actual yield. So we now find the percentage yield. Percentage yield therefore will now be equal to actual yield, which is 5.9, over theoretical yield, which is 17.2 times 100. So the percent yield of aspirin is 34%. It's 34%. So the implication is that since the percentage is a bit low, you might decide not to continue with the experiment. But if it's a bit higher, maybe 50 or 54 upward, you can decide to continue with the experiment. That's the implication of percentage yield. It tells you are we really making progress with this experiment? Can we proceed or not? And so that's how to calculate percent yield. Now we'll be looking at solving some past questions now. We're going to be looking at solving some past questions uh, on stoichiometry. So let's look at question number 1. We're 2010. The question says consider the neutralizing reaction represented by the following equation. Sodium hydroxide plus 2095 to give sodium 2095 plus water plus CO2. The stoichiometric ratio of acid to base is the base here is this base here is sodium transcarbonate 4, and the acid here is 2095 acid. So the question now says the ratio of acid, stoichiometric ratio of acid to base. You just look at your equation. That's where you get your stoichiometric ratio from. Beside sodium transcarbonate 4, you only have just 1. Then beside 2095, you have 2. So the ratio is 2:1, and the correct answer is B. Let's look at question on moles. The question says how many moles of iron molecules will react with 0.72 moles of oxygen to molecules in this given equation. This is a stoichiometric question. When you have balanced this equation like this, that's stoichiometrically now 4 moles of iron reacting with 3 moles of oxygen to produce 2 moles of iron 3 oxide. So how do you calculate the molecules? You have 4 moles of Fe reacting with 3 moles of O2 to produce 2 moles of Fe2O3. Then the mole ratio of iron and oxygen is 4:3. So we can now say let 0.27 moles of O2 react with X mole of iron. So Fe ratio O2 will now be X ratio 0.27. So if you want to now compare, we can now say 4:3 is equal to S ratio 0.27. If you cross multiply, your X will now be equal to 4 times 0.27 over 3. That's 0.6 mole. So 0.36 moles, 0.36 mole of iron molecules react with 0.27 moles of oxygen molecules. Or we can also say, like we usually do, 4 moles of iron is equal to 3 moles of oxygen. Then X mole of iron will go to 0.2 moles of oxygen. Then you cross multiply. The ones you cross multiply, you are going to have 4.027 divided by 3. It will give you 0.36 moles of iron. Okay, so another question: if how many moles of ammonia are produced if 4.20 moles of hydrogen are reacted with an excess of nitrogen? Ammonia is formed by reaction of N2 plus H2 to give 2NH3. N2 plus 3H2 will give 2NH3. From that equation, again, 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. And so then 4.20 mole of hydrogen produces the number of moles of ammonia. The 4.20 mole of hydrogen that produces the number of moles of ammonia is that. From that equation again, you have our focus here is between hydrogen and ammonia. So you are going to have hydrogen ratio ammonia. That's what we want to do. So from the actual mole, you are going to have 2. Hydrogen is 2, hydrogen is 3, ammonia is 2. Therefore, you're going to have 3:2. That's the stoichiometry, what's it called? Stoichiometry ratio now, 3:2. So to make a reaction now, we have 4.2 moles of hydrogen. So we cannot do it this way. 3:2 is equal to 4.2 ratio x. 3:2 is equal to 4.2 ratio x. Then x will now be equal to 4.2 times 2 over 3. And that will become 2.8. So 4.2 moles of H2 produces 2.8 moles of ammonia. 8 moles of ammonia. So let's look at some questions involving stoichiometric conversions. That's mass to mass, mass to volume, and volume to volume. The first question, this is also a wire question. You have to consider CaCO3 reacting with HCl to give CaCl2 plus H2O to CO2 plus CO2. The question says what mass of CaCl2 will be obtained when 12.50 gram of CaCO3 is reacted with excess HCl. This is a mass conversion because you are given the mass of one of the known and you are asked to find the mass of the unknown. Okay, to do that, the first thing to do again when you are solving questions like this is to convert the mass to mole, then relate them, then find the unknown. Very simple. The first question, WAEC has helped you to write out the equation. For other exams, you have to write out the equation and balance them. That's the step 1. Step 2, convert whatever mass you are given to mole. So you want to convert the mass of CaCO3 to mole by saying mass, number of moles is equal to mass over molar mass. That's amount of CaCO3 that reacted, therefore, is equal to mass over molar mass. And the molar mass of CaCO3 is 100 gram per mole. So amount, therefore, is equal to 12.50 over 100. That's 0.125 moles. That's step 2. Your step 3, I said step 1 is balance the equation. Step 2 is converting whatever mass you are given to mole. Step 3 now is to now do the stoichiometry of that question by saying from the equation 1 mole of CaCO3 produces 1 mole of CaCl2. So since they have the same stoichiometric ratio, so whatever mole you get in the known will be the mole for the unknown. So we say 1 mole of CaCO3 reacted to produce 1 mole of CaCl2. Therefore, 0.125 mole of CaCO3 will still be the same as 0.125 moles of CaCl2. So the actual moles of CaCl2 also is 0.125 mole. So it's now easy for us to find the mass of CaCl2. What we need to do is to just multiply the amount times the molar mass of CaCl2. That's 0.125 times 111, and it will give us 13.9 grams. So the mass of CaCl2 produced is 13.9 grams. We are going to do this second question the same way. You are given sodium hydrogen triazocarbonate 4. It decomposes to produce sodium triazocarbonate 4 plus H2O plus CO2. We have to find the mass of Na2CO3 produced when a particular mass of 16.8 gram of sodium hydrogen triazocarbonate 4 is completely decomposed. So again, you convert whatever after writing and balancing equation. They have done that for you. This step 1 for you. You convert the mass to mole by saying mass over molar mass. That's 16.8 over 84. That's 0.2 moles. Then you go back the third step 3 again, the stoichiometry of the equation. You now say 2 moles of NaHCO3 produces 1 mole of Na2CO3. Then 0.2 moles of NaHCO3 will now produce 0.2, which is the mole of the known, over the mole ratio. Don't forget, over the mole ratio of the unknown divided by mole ratio of the known. So that's 0.2 times 1 over 2, which is equal to 0.1 moles. So the actual moles of Na2CO3 is 0.1 moles. From there now you can find the mass by saying amount times molar mass. That's 0.1 times 106. That's 10.6 gram. For WAEC, ensure that you find the molar mass of. If you are not given the molar mass of the compound, make sure you solve it out because it attracts mark. Now let's look at the mass volume now. The mass volume problem. Let's assume you are given the mass and asked to find volume, or you are given the volume and asked to find mass. If you consider this reaction, that's zinc reacting with HCl to produce zinc chloride and hydrogen gas. You have to look for the volume of oxygen gas produced at STP when 6.5 gram of zinc reacts with excess HCl. Please take note again. This was going to be slightly different from what we have been doing. However, it still follow the same process. Step 1, write out the equation and balance. They've done that for you. Step 2, convert mass to mole. That's the mass of zinc was given there. That's finding the mole. That's mass over molar mass. That's 6.5 over 65. It should give you 0.1 moles of zinc. Then another was is to do the stoichiometry of the equation. 1 mole of zinc produces 1 mole of H2 gas. Therefore, 0.1 mole of zinc will still be equal to 0.1 mole of H2 gas. That means the actual mole of H2 gas is 0.1 moles. The next thing now is to find the volume of H2 that was produced. Here now the formula will change. Recall that the amount of substance is equal to volume of a gas in dm cube over molar volume at STP. And the molar volume of a substance at STP is equal to 22.4 dm cube. So if you now make volume of the gas a subject of formula here, so volume of the gas will now be equal to amount times molar volume at STP. And the amount of H2 gas that we got is 0.1. Molar volume is 22.4. So 0.1 multiplied by 22.4 will give us 2.24 dm cube of hydrogen gas. So 2.24 dm cube of hydrogen gas was produced. Now let's look at the second question. Now in the first one you were given mass and they asked you to find volume. Now you have been given volume and they ask you to find mass. It's still a mass volume problem. Okay, so the question says the composition of hydrogen peroxide to give water and O2. We are looking for the mass of the peroxide, which is required to produce 22.4 dm cube of oxygen. Now, mass and volume are quantitative values that are used to measure a particular substance. So, if you are given mass, you convert to mole. If you are given volume, you also convert to mole. Therefore, the volume that was given there, we convert it to mole by saying amount is equal to volume over molar volume. And that's the volume over 22.4. So the volume given here is 22.4. So the amount of O2 at STP here is volume over molar volume, which is 22.4 over 22.4. That's 1 moles. Then the next step is to do stoichiometry of that question by saying that 2 moles of H2O2 gave 2 moles of water and 1 mole of O2. Therefore, 1 mole of O2 will now be equal to 2 moles of H2O2. Yes, from that equation, 1 mole of O2. If 2 moles produce 1 mole, then 1 mole of O2 will now produce 2 mole again. So, so the actual mole of hydrogen peroxide is 2 moles. Then we have to look for the mass. To get the mass, mass is amount times molar mass. Then we find the molar mass of H2O2. So mass therefore is equal to 2 multiplied by 34, and that's 78 gram of hydrogen peroxide. Then now let's look at question relating to mass and volume again. You were given in a particular equation carbon reacting with oxygen to form CO2, and then you are given the mass of CO2. you have to look for the volume of oxygen. That means you are given the mass of the product. You are looking for the volume of the reactant. So what you do again is, after balancing the equation, you convert the mass to mole. To convert the mass to mole, that's 2.20 over 44, because CO2 is 44. It will give you 0.05 moles. Then you do the stoichiometry of the equation again. 1 mole of carbon equivalents to 1 mole of O2 and 1 mole of CO2. Therefore, since they have the same stoichiometric ratio, 0.5 mole of carbon is still the same as 0.5 moles of CO2 and 0.5 moles of O2. So the actual moles of O2 here is 0.05 moles. Then to calculate the volume, that's amount times molar volume. That's 0.05, that's 22.4, is equal to 1.12 dm cube. So let's look at question relating to volume. You are given a particular volume and they ask you to find volume. The question says, what volume of oxygen at STP is equal to bond completely? 15.0 dm cube of methane according to that equation. From that, this is the equation. You are given the volume. Like I've said, you convert the volume to mole. The volume of amount of methane at STP will now be volume over molar volume. That's 15 over 22.4. That's 0.67 moles. The next step is to find the stoichiometry of the equation. If you balance the equation very well, you know that 1 mole of CH4 is equal to 2 moles of oxygen. Yes, 1 mole of CH4 is equal to 2 moles of oxygen. Then 0.67 moles of CH4 will now be 2 times 0.67, which is 1.34 moles of oxygen. Then volume of CO2 that at STP will now be amount times molar volume. That's 1.34 times 22.4, and that's 30 dm cube. That's 30 dm cube. So let's solve one more question. Now under volume, it can also be given question in this way. Instead of giving you volume, they can give you concentration and volume. The same process is being followed. If you are given concentration and volume, you need to still convert concentration and volume. You need to still convert to mole. Remember that amount is equal to concentration in mole per dm cube or molar times volume in dm cube. So you still convert to amount or mole. So to convert now, the amount of H2SO4 will now be the concentration, which is 2 times volume in dm cube. The reason why we are having 25 over 1000 is because the volume must be in dm cube. That's 25 divided by 1000. That's 2 times 0.025, and that's 0.05 moles. So we have been able to convert H2SO4 to mole. Then we now do the stoichiometry again by saying 1 mole of H2SO4 reacts with 1 mole of ZnCO3 to produce 1 mole of ZnSO4. Therefore, since they have the same stoichiometric ratio, so 0.05 mole of H2SO4 is still the same as 0.05 moles of ZnSO4. So the actual moles of ZnSO4 is 0.05 mole. To now find the mass, mass is amount multiplied by by molar mass. So I think from that question we are given the molar mass to be 161. So multiply by the amount, that's 8.05 gram. So far in this lesson we have looked at percentage yield and limiting reagents, and how you can calculate for the limiting reagents. We have also looked at stoichiometric conversions, mass to mass, mass to volume, volume to mass, and volume to volume. So we have been able to extensively look at stoichiometry, mole ratio, and stoichiometric conversions. Do well to take more questions on mole ratio. We did calculations on mole ratios too as well. Do well to take more questions, more wire question on mole ratio, percentage yield, and of course stoichiometry conversions. Continue to learn chemistry till we meet in the next video. Bye bye for now.